Welcome to our lesson on measures of center in statistics. In this video, we'll learn about different ways to find the middle or center of a data set. When analyzing data, we often want to find a single value that represents the center of our data. There are four common measures of center that we'll explore today: the mean, the median, the mode, and the mid-range. Throughout this lesson, we'll use this example data set representing wait times in minutes for a popular ride at an amusement park. The wait times in minutes are 50, 25, 75, 35, 50, 25, 30, 50, 45, 25, and 20 minutes. Let's start with the mean, also known as the arithmetic mean. The mean is calculated by adding all the data values and dividing by the number of values. It's the most common measure of center, but people often imprecisely call it the average. Let's calculate the mean of our wait time data. We add all 11 values: 50 plus 25 plus 75 plus 35 plus 50 plus 25 plus 30 plus 50 plus 45 plus 25 plus 20, which gives us 430. Then we divide by the number of values, which is 11. 430 divided by 11 equals 39.1 minutes. So the mean wait time is 39.1 minutes. The mean has some important properties to keep in mind. First, the mean uses every data value in the calculation. Second, the mean is not resistant to outliers. This means that extreme values can significantly change the mean. If one wait time was extremely long, like 500 minutes instead of 75, the mean would be much higher. Now, let's look at the median. The median is the middle value when the data is arranged in order. If we have an odd number of values, the median is the exact middle value. If we have an even number of values, the median is the average of the two middle values. Let's find the median of our wait time data. First, we need to sort the values in ascending order: 20, 25, 25, 25, 30, 35, 45, 50, 50, 50, 75. Since we have 11 values, which is odd, the median is the middle value, which is the sixth value: 35 minutes. The median has some important properties too. Unlike the mean, the median is resistant to outliers. This means that extreme values don't affect the median much. For example, if we change 75 to 500, the median would still be 35 minutes. Let's see what happens when we have an even number of values. If we add another wait time of 50 minutes to our data, we now have 12 values. The sorted values are 20, 25, 25, 25, 30, 35, 45, 50, 50, 50, 50, 75. With 12 values, the two middle values are the sixth and seventh values, 35 and 45. The median is the average of these two values. 35 plus 45 divided by 2 equals 40 minutes. Our third measure of center is the mode. The mode is the value that occurs most frequently in the data set. Unlike the mean and median, a data set can have no mode, one mode, or multiple modes. Let's find the mode of our wait time data. In our data, 20 occurs once, 25 occurs 3 times, 30 occurs once, 35 occurs once, 45 occurs once, 50 occurs 3 times, and 75 occurs once. Both 25 and 50 occur 3 times, more than any other value. So our data set has two modes: 25 minutes and 50 minutes. This makes our data bimodal. Our final measure of center is the mid-range. The mid-range is the average of the minimum and maximum values in the data set. It's found by adding the smallest and largest values, then dividing by 2. Let's calculate the mid-range of our wait time data. The minimum value is 20 minutes, and the maximum value is 75 minutes. The mid-range is 20 plus 75 divided by 2, which equals 47.5 minutes. The mid-range also has some important properties. Like the mean, the mid-range is not resistant to outliers. In fact, it's even more sensitive than the mean because it only uses the two extreme values. If we change 75 to 500, the mid-range would change dramatically from 47.5 to 260 minutes. Let's summarize what we've learned about the four measures of center. For our wait time data, the mean is 39.1 minutes. The median is 35 minutes. The modes are 25 and 50 minutes. The mid-range is 47.5 minutes. When deciding which measure to use, consider the shape of your data distribution. If your data is symmetric without outliers, the mean is generally preferred. If your data is skewed or has outliers, the median is often a better choice because it's resistant. The mode is useful for identifying the most common values, especially with categorical data. The mid-range is rarely used in practice, but helps illustrate the effect of extreme values. In conclusion, understanding the different measures of center is essential for accurately describing data. Each measure has its strengths and weaknesses, and choosing the right one depends on your data's characteristics and what you're trying to communicate. Thank you for watching.